Hello friends, today let's prove one theorem from the topic similarity class 10th, and the theorem is theorem of areas of a similar triangle. So first of all let us have the statement of the theorem. When two triangles are similar, then the ratio of areas of those triangles is equal to the ratio of the squares of their corresponding sides. So this is the statement of the theorem. Now let's illustrate this theorem with the help of a diagram. So these are the two triangles given, triangle ABC and triangle PQR. So these two triangles are given to be similar, and for those two triangles the given would be triangle ABC is similar to triangle PQR, which is given, where AD is perpendicular to BC. So for triangle ABC, AD is the height and BC is the base. In the same way, PS is perpendicular to QR, that means PS is the height and QR is the base for triangle PQR. So this is given, and from this we have to prove that if we take the ratio of areas of these two triangles, that is area of triangle ABC divided by area of triangle PQR, it must be equal to, it is given that the ratio of squares of their corresponding sides. So the first ratio is AB divided by PQ, and we have to make it square. That's why it is AB square by PQ square. So this is the first ratio of the corresponding sides. As it is a triangle, it must have three sides, that means it must have three ratios. The second ratio is BC square divided by QR square, because BC and QR are the corresponding sides, and the remaining ratio is AC square by PR square. So this is we have to prove area of triangle ABC divided by area of triangle PQR is equal to AB square by PQ square is equal to BC square by QR square is equal to AC square by PR square. Now let's have the proof of the theorem. So we'll start with the given thing. That means as these two triangles are given, AD is perpendicular to BC and PS is perpendicular to QR, and that's why we have another pair of triangles, that is triangle ADP and triangle PSQ, or in other words we can name these triangles as triangle ABD and triangle PQS. So these two triangles, we have to show that these two triangles are similar. So the first element is angle B is congruent to angle Q. As triangle ABC is similar to triangle PQR and angle B and angle Q are the corresponding angles, so they must be congruent. So that's why the reason is given. So for these two triangles, angle B is congruent to angle Q. The second element is angle ADB. This angle must be of measure 90 degree because AD is perpendicular to BC. In the same way, angle PSQ is also 90 degrees. So these two angles must be congruent as each has a measure of 90 degrees. So by having these two elements, we can have these two triangles similar by AA test. That's why triangle ABD is similar to triangle PQS by AA test. And we know one property of similar triangles, that if two triangles are similar, then the corresponding angles are congruent and corresponding sides are in proportion. So we'll take here AD divided by PS. So AD means first and the third vertex. Its corresponding side is PS. That's why the first ratio is AD divided by PS. That must be equal to AB divided by PQ. So to take AB, first and the second vertex we have to take, and the corresponding side would be PQ. So the second ratio is AB divided by PQ. And we can take this because these are the corresponding sides of similar triangles. So that must be the reason, and we'll call this as equation number 1. Now it is given that triangle ABC is similar to triangle PQR. So if these two triangles are similar, then their corresponding sides must be also in proportion. So if we take side AB, its corresponding side would be PQ. So AB divided by PQ is equal to BC divided by QR. Again, the reason is same here. Corresponding sides of similar triangles. We'll call this as equation number 2. Now we have to take the ratio of areas of these two triangles. So if we take the ratio of areas of these two triangles, that is area of triangle ABC divided by area of triangle PQR, the basic formula is, if two triangles are there and if we have to take the ratio of their areas, the formula is the ratio of corresponding bases and heights of those two triangles. So area of triangle ABC divided by area of triangle PQR is equal to BC into AD, as BC is the base for first triangle and AD is the height, divided by QR into PS, as QR is the base and PS is the height for the second triangle. So it can be split as BC by QR into AD divided by PS. Now to the next step, the first ratio would be as it is BC by QR into, instead of AD by PS we can write BC by QR. Now why is this so? Because of equation number 1 and equation number 2. Let's see how it is. AD divided by PS is equal to AB divided by PQ, and AB divided by PQ is equal to BC divided by QR. That's why we can say that AD divided by PS must be equal to BC divided by QR. So from equation 1 and 2, instead of AD divided by PS, we can write BC divided by QR. And to the next step now, we have BC divided by QR into BC divided by QR, that's equals to BC square divided by QR square. Now this is area of triangle ABC divided by area of triangle PQR is equal to BC square by QR square. So as we have proved this theorem for one corresponding side of a triangle, in the same way we can prove it for remaining two also, and hence we get the result as area of triangle ABC divided by area of triangle PQR is equal to AB square by PQ square is equal to BC square by QR square is equal to AC square by PR square. So this is the theorem of areas of similar triangles.